Students, we'll continue with further part of module 2, the last part. Okay. The statement of the problem is, using Mason's gain formula, determine y of s by x of s for the signal flow graph shown below. Okay. So this is a signal flow graph and we have to find the y of s by x of s. So when we see the signal flow graph, then first step is we have to find the forward path gains. So if you see, there is only one forward path. Okay, there is only one forward path and that will denote by T1, and we'll write the gain of that forward path, which is given by T1 equal to 1 into k into 1 into s raised to minus 1 into s raised to minus 1 into s raised to minus 1 into 1. This is only the forward path. That is why we'll get it as k divided by s square. I'll repeat. So 1 into k into 1 into s raised to minus 1 into s raised to minus 1 into s raised to minus 1 into 1, which will come equal to k divided by s cube. Okay, k divided by s raised to 3. Then various loop gains are there. So how many loops are there? We'll identify. If you see, there are 4 loops and we'll write the loop gains. First loop gain is given by L1. L1 is equal to s raised to minus 1 into minus 2. Okay, so this is the first loop. This is the first loop. This s raised to minus 1 into minus 2. S raised to minus 1 into minus 2 is first loop gain. This is minus 2 by s. Second loop L2. L2 is given by s raised to minus 1 into s raised to minus 1 into this minus 2. So I'll repeat, s raised to minus 1, s raised to minus 1 into minus 2 is second loop gain denoted by L2. So L2 is s raised to minus 1 into s raised to into minus 2, which is minus 2 by s square. Got it? Next third loop will be 1 into s raised to minus 1 into s raised to minus 1 into minus 1. So this is 1 into s raised to minus 1 into s raised to minus 1 into this minus 1. So it is minus 1 divided by s square. Next fourth loop will be this one, k into 1 into s raised to minus 1 into s raised to minus 1 into this minus 1. I'll repeat, k into 1 into s raised to minus 1 into s raised to minus 1. Got it? Into minus 1. So this is a fourth loop. Got it? So which will come equal to minus k by s raised to minus 2. Then how many combinations of 2 non-touching loops or 3 non-touching loops are there? If we see, there is no combination of 2 non-touching loops or more non-touching loops. So no combination of 2 non-touching or more non-touching loops. So delta we can write it as 1 minus L1 plus L2 plus L3 plus L4, which is 1 plus 2 by s square plus 2 by s square plus 1 by s square plus k by s raised to 3. All the loops are touching to the forward part T1, so delta 1 is equal to 1. Therefore, y of s by x of s is equal to T1 delta 1 by delta, which is equal to k by s raised to 3 divided by 1 plus 2 by s plus 2 by s square plus 1 by s square plus k by s raised to 3, which is equal to k divided by s raised to 3 plus 2s square plus 3s plus k. Okay. So y by s by x by s is equal to k divided by s raised to 3 plus 2s square plus 3s plus k. So we'll take the next problem. Find the transfer function c of s by r of s for the signal flow graph shown. Okay, this is a signal flow graph. We have to find c of s by r of s. If we see the signal flow graph, so we'll write the first step as the solution. So step 1 is identify how many number of forward paths are there. There is only one forward path. We'll write that path again, which is denoted by P1. So P1 is equal to G1 into G2 into G3 into G4 into G5. So it is G1 into G2 into G3 into G4 into G5. So there is only one forward path. Then second step, we'll find how many number of individual loops are there and we'll write the loop gains. There are 4 individual loops and we'll write the path gains. Okay, so first loop is gain is denoted by L1. So L1 is this loop, inner small loop. It is minus G2H1. So this is minus G2H1, which is due to this G2 into minus H1. So minus G2H1. L2 we can write it as this one. L2 we can write G4 into minus H2. So G4 into minus H2 is minus G4 H2. Next we'll write L3. L3 is this loop. G7 into minus H3. I'll repeat. G7 into minus H3, which is minus which is minus L3. I have written minus G7 into H3. Next L4 is this loop. G2, G3, G4, G5, G6, G7, G8. Got it? So L4 is G2, G3, G4, G5, G6, G7, G8. Okay, so these are the 4 individual loops with loop gains. Okay, next, how many combinations of 3 non-touching loops are there taken 2 at a time? So we'll see that first. Okay, how many there are. What we have to do now, next step is how many combination of 2 non-touching loops are there, we have to see. Then we write all the combinations of 2 non-touching loops taken at a time. So loop 1 and loop 2 are non-touching. So take the product of loop 1 and loop 2 gains, which is given by this L1 L2 is equal to G2 H1 G4 H2. Next, loop 1 and loop 3 are non-touching. So L1 L3 will become G2 H1 G7 H3. Loop 2 and loop 3 are non-touching. So L2 L3 is equal to G4 H2 G7 H3. Step 4. So take 3 loops at a time and write their loop gains provided they are non-touching. When we see there is only one combination of 3 non-touching loops taken at a time, we'll write that. So loop 1, 2 and 3 are non-touching. Loop 1, 2 and 3 are non-touching. So take the product of all those loops. L1, L2, L3 is equal to minus G2, H1, G4, H2, G7, H3. Find the determinant. Determinant of graph is delta is equal to 1 minus L1 plus L2 plus L3 plus L4 plus L1, L2 plus L1, L3 plus L2, L3 minus L1, L2, L3. Step 6. Find delta K. Find delta K. As there is only one forward path, so K is 1. When K is 1, delta K will become equal to delta 1. How to find delta 1? Delta 1 is found by eliminating the loop gains. That is the first forward path delta. So delta 1 is 1 minus 0 plus 0 plus L3 plus 0 plus 0 plus 0 plus 0 minus 0. If we see L1 is touching forward path, L2 is touching forward path, L4 is touching forward path, L1, L2 are touching forward path, L1, L3 are touching forward path, L2, L3 are touching forward path, L1, L2, L3 are due to that all these terms are 0. Only L3 is not touching the forward path, so L3 is kept here to find delta 1. So which will come 1 minus L3, which after substituting L3 we get 1 plus G7 H3. Using Mason's gain formula, C by R is P1 delta 1 by delta. So substitute P1, substitute delta 1, substitute delta. What we'll get is G1, G2, G3, G4, G5 into 1 plus G7H3 divided by delta. Delta is 1 minus of G2H1 minus G4H2 minus G7H3 plus G2, G3, G4, G5, G6, G7, G8 plus G2H1, G4H2 plus G2H1, G7H3 plus G4H2, G7H3 minus of minus G2H1, G4H2, G7H3, which will come equal to G1, G2, G3, G4, G5 into bracket 1 plus G7H3 by delta. Delta is substituted here, which will come 1 plus G2H1 plus G4H2 plus G7H3 minus minus G2, G3, G4, G5, G6, G7, G8 plus G2H1, G4H2 plus G2H1, G7H3 plus G4H2, G7H3 plus G2H1, G4H2, G7H3. Okay, so that is C by R. We'll take next problem. This is the different aspect of problem. Draw the corresponding signal flow graph of given block diagram and find C by S of R of S. Okay, we have to draw the signal flow graph of given block diagram and find C of S by R of S. So first, how many summing points are there? Name all the summing points and take up points of the given block diagram. So S1, S2, got it? T1, this is S3, this is T2. So locate all those here. Push S1, S2, T1, T2, etc. Then you see input is R of S given by R, C of S is output. C of S output. Then at S1 we have one feedback signal denoted by H2. So H2 is with plus sign. So it is written plus H2. Next, for S2 summer we have input output of S1 plus this H1. H1 is going to S2. So it is given as minus H1 to here S2. Then S2 to T1. S2 to T1 you have two blocks in series. So two blocks in series is G1, G2. So G1, G2 is present in between S2 and T1. Okay. Then again from T1 we have one block G4 connected to S3. Okay. Forward path. So T1 to S3 is denoted by G4 here. Then from T1 to T2. From T1 to T2 it is still here. From here to here. So T1 is a block G3, then it is given to S3. So T1 to S3 denoted by G3. From S3 to T2 we have 1. Okay. So this is how to draw the signal flow graph. Then to find C of S by R of S, use Mason's gain formula. First you find how many number of forward paths are there. K is equal to 2 number of forward paths. Write the path gains. P1 is equal to G1, G2, G3, P2 equal to G1, G2, G4. So C of S by R of S is P1 delta 1 plus P2 delta 2 by delta. Individual feedback loops are, so how many feedback loops are there? You find out from this. It is shown here. These are individual. So this is one feedback loop, G2, G1, G1, G2 minus H1. This is G1, G2, G3, H2. this is G1, G2, G4 minus H2. Okay, so those two are written. Then how many number of two loops are there non-touching at a time? So there are three loops which are non-touching at a time. They have been written. Then find which loops are touching the forward path. P1 all loops are touching, delta 1 is 1. P2 all loops are touching, delta 2 is 1. So C of S by R of S is P1 delta 1 plus P2 delta 2 by delta. So P1 is determined, delta 1 is 1, P2 is determined, delta 2 is 1 by delta. Delta is 1 minus L1 plus L2 plus L3. Okay, so delta is 1 plus G2 G1 H1 minus G1 G2 G3 H2 minus G1 G2 G4 H2. Here it is. These are the three. So this is what is delta 1 L1 L2 L3. This L1 L2 L3. Okay, so C of S by R of S is G1 G2 G3 plus G1 G2 G4 by 1 minus G1 G2 G3 H2 minus G1 G2 G4 H2 plus G1 G2 H1. Okay, this is how to find. We'll take the next problem. Obtain the block diagram for the signal flow graph shown below. So this is reverse process. Signal flow graph is given. We have to find the block diagram of that signal flow. So first we'll see to the nodes which are incoming signals. First we'll take this Y. One incoming signal is to S. One is feedback signal -4 coming from Z. One is from U which is -5. So Y we can write it as 2S into X minus 4Z minus 5U. Next we'll go for Z. For Z we have 3 into Y minus 3 into W, this one. Next we'll go for W. For this W we have 2 into Z. Only this one, 2 into Z. They should be incoming to that node. Okay. U is equal to, for this U we have W into 1 plus 5 into, okay, 5 into Z. This 5 into Z. Next, so equation 1, first you take node X, then from Y you write all that. So this is X, this is Y. From X to summing point to S, from Y you have, just a minute, I'll repeat. So take X input, take Y node. Then in between X and Y, what all is present, you draw that. 2S is in between X to summing point. From summing point there is 4 coming from Z, which is minus. From U is coming 5 signal with minus. So equation, and similarly for next Y to Z. Y to Z, 3Y is coming to a summing point. One more signal, 3W is with minus coming to summing point from there to Z. Next equation 3, Z to W. So Z into 2 will be W. Equation 4, from W to U. Okay, this summing point, this one. Combine all the simulations and repositing branches. So combine all this. So from your right from, take this node Y. How to drive it? For Y what we have, 2S into X. So 2S into X is to a summing. Then it is minus 4Z. Minus 4Z means to the summing point minus 4 into 4 from Z. Then one more is minus 5U. So from U take and give it to a block 5, they'll get multiply U. It is with minus 5 means minus. So Y is 2S into X minus 5U minus 4Z. So got it? Next, what you have for Z? 3Y minus 3W. So Z should be with 3y minus 3w. 3y and 3w are given to summing point, but it is 3y minus 3w. So this should be minus. Z now will get 3y minus 3w. What is third equation? W equal to 2z. So w must be equal to 2z. Z into 2. Equation 4, u is 1 into w plus s 5 into z. So u is 1 into w plus 5 into z. Combine all those four blocks, you'll get this. You'll get this block diagram. So this is y, this is z, this is u. All combined, you'll draw this block. Combine all those blocks, you will get this block diagram. Okay, so this, I'll stop here.